Hello grade 9 students, in this video we're going to review how to name branched chain alkanes. Now hydrocarbons, as you know, are the most simplest organic compounds. They contain only the elements carbon and hydrogen. Now hydrocarbons are classified into two different classes. We have the aliphatic hydrocarbons and we have the aromatic hydrocarbons. Aromatic hydrocarbons contain the benzene ring and they will be cancelled for this year. So our main concern is on aliphatic hydrocarbons. Now aliphatic hydrocarbons are classified into four different families. First we have the alkanes, in where we have a single covalent bond between two consecutive carbon atoms. We have the cycloalkanes, where the carbon atoms form a ring or a cycle. We have the alkenes, where we have a double covalent bond between two consecutive carbon atoms. And we have the alkynes, where we have a triple covalent bond between two consecutive carbon atoms. Now, alkanes, as you know, they contain only single covalent bonds. They are said to be saturated hydrocarbons because each carbon is bonded to the maximum number of hydrogen atoms it can bond to. Now, if we take a look at this previous slide, you can see that the carbon atom is bonded to 3 hydrogen atoms, and that's the maximum number of hydrogen atoms it can bond to. While if we take a look at the alkenes, the carbon atom here is bonded to only 2 hydrogen atoms instead of 3, so more hydrogen atoms can be added to the alkene or alkyne compound, and therefore these compounds, alkenes and alkyne molecules, are referred to as unsaturated, while alkanes are said to be saturated hydrocarbons. Now carbon atoms in an alkane molecule can be arranged in a straight, cyclic, or branched way. Now, whenever we say straight, some people confuse that with a straight line, and what we mean is that the chain is continuous. Now, when we say the chain is continuous, it means that I have to move from the beginning till the end without stopping at any point, as you can see here. So this chain is referred to a continuous chain. It is a butane molecule. Now, in this second example, also refers to a butane molecule. The only difference is that it's a little bent, but it's still continuous, as you can see, because I did not stop at any point. All of these other examples are also straight chains where the chain is continuous. Now, the second arrangement of carbon atoms in an alkane is the cyclic form. Now, whenever we say cyclic, you have to remember that the carbon atoms are arranged in form of a ring or a cycle. Their general formula is CnH2n because 2 hydrogen atoms have to be removed in order for the carbon atoms to form a ring. They begin with at least 3 carbon atoms because that's the smallest possible number that you need in order to form a ring. Now, the name of the compound is preceded by the prefix cyclo to indicate that we have a ring. Now you can see cyclopropane here, propane because we have 3 carbon atoms, and the prefix cyclo to indicate that it is cyclic or that we have a ring. Cyclobutane, cyclopentane, cyclohexane. Now, the molecular formula shows you that the number of hydrogen atoms is twice the number of carbon atoms. Now, the last arrangement of carbon atoms in an alkane is the branched chain form. Now, whenever we say a branched chain, it means that the chain is non-continuous. Now, as you can see the difference between the two examples here, in the first chain here, it's a continuous chain because it is straight, it's continuous, I did not stop at any point. In the second example, you're going to see that when I reach the second carbon, I have to stop and decide which way I'm going to take. I'm going to continue downwards or to the right. And therefore, my chain was interrupted and it's non-continuous. And this is what we call a branched chain. In the branched chain, as you can see, this carbon, which is attached to the main chain is the continuous straight chain, which is this one. It's called a branch. Now, we might have one branch, two branches, or even more. This CH3 group is called an alkyl group, and it has the general formula CnH2n+1 because one hydrogen atom has been removed from the methane in order to bond to the main chain. Now, these alkyl groups are formed by removing a hydrogen atom. As you can see in the first example, one hydrogen atom has been removed from the methane molecule, and therefore we obtain methyl. And in the ethane molecule, one hydrogen atom has been removed, and we obtain the ethyl group. Now, the condensed structural formula of these groups are shown in the above table. Now, our concern is how to name the branched chain alkanes. They are named according to the International Union of Pure and Applied Chemistry. Now, there are 4 steps, and they are very easy to follow. Now, we're going to start with one example to show you how. Now, the first way is to identify the longest continuous chain. Now, here, as you can see, we have 2 long continuous chains. We have the straight one, and then we have a bent one. Either way works. So first we have to identify the longest chain, and then I have to identify the branch. Now here it's a methyl group. It is attached to the second carbon. We have to number the carbon atoms of the main chain in such a way that it gives the branch the lowest number. Now, we started numbering from the right side because it gives the carbon that holds this methyl group number 2. Well, if we number from the left side, the number of the carbon atom holding the methyl group would be number 4, and this is a larger number, so it's an incorrect way. The first way is the correct one. Now, in order to construct the name of the branched chain alkane, we begin with the name of the main chain. Now, the main chain consists of 5 carbon atoms, and therefore, we have to start by writing the name pentane, as you can see here. So, the name of the main chain is written at the end, as you can see here, which is pentane. Then we proceeded by the name of the substituent or the branch, which is methyl, and we proceeded by the number at which this methyl group is connected, which is number 2. So the name becomes 2-methylpentane. The number and the letter are separated by a dash. Now, sometimes we might have 2 or more identical branches. If we have 2 identical branches, we use the prefix di. If we have 3, tri, and if we have 4, tetra. Now, in this example, we have 2 identical branches, which are methyl groups. The same rules apply, but we have to insert a prefix to indicate the number of the branches. Now, our longest continuous chain consists of 7 carbon atoms, so the name has to end in heptane, sorry. Now, because we have 2 methyl groups, we have to add the prefix di, as you can see here. So, dimethylheptane. And, of course, we have to show the location of each branch. Now, the first methyl group is connected to number 2, and the second one is connected to number 4. The numbers are separated by a comma. Now, we didn't number from this side, which is the right one, because it would give the branches, the carbons holding the branches, numbers 4 and 6 if we were to number from this side. So this numbering from the right side is incorrect, and we chose to number from the left side to give these carbons the lower numbers. Now, if we have 2 or more different groups joined, we have to write the groups in an alphabetical order. It's always ethyl before methyl. Now, if we take a look at the main chain, you can see that the main chain consists of 6 carbon atoms. Now, the methyl group is connected to the second carbon in the main chain, and the ethyl group here is connected to the fourth carbon. Now, we have a methyl, which is connected to the second carbon. We have an ethyl connected to the fourth carbon. So the name of the main chain is hexane. We have to write either the methyl or the ethyl first. Of course, because ethyl comes before the methyl alphabetically, we have to begin with the ethyl, and therefore the name becomes 4-ethyl 2-methylhexane. Now, as a remark, in case the numbering from both sides gives the same number, we start from the side that gives the branch coming first in the alphabetical order the lowest number. Now, as you can see in both cases, the number of the carbons holding the branches are 3 and 5. If we number from the left or from the right side, but because this numbering from the left side gives the ethyl group the lower number, which is a 3, the first name is the correct one because it gives this ethyl number 3, which is lower than number 5, and the name is 3-ethyl 5-methylheptane. Now here we have a couple of examples for you to practice. You can practice naming these compounds. Now the same rules apply. In the first, for example, we're going to search for the longest chain, and then we're going to circle the branches. The longest chain consists of 3 carbon atoms, and that's why it is called propane. And each branch is a methyl, so that's why they're 2. So we have to use the prefix dimethyl, and they're connected to the second carbon. In either way, number will give us the same number, so the name will be 2,2-dimethyl propane. In the second here structure, we have a main chain of 4, and we have 2 branches. Now we have to number from this side because this carbon atom will receive the number 2, while if we number from the left, it's going to receive the number 3. So we're going to number from the right. Now, as we said, we name the main chain, which is 4 carbon atoms, meaning it's butane. We have 2 identical branches. We have to use prefix di, and finally we number each branch. Now the first branch is connected to the second, and the second is also connected to number 2. So the name becomes 2,2-dimethyl butane. Now in the third structure, we have 2 ways for the main chain. We have this one or this, either way works, but we have 2 different branches. We have the methyl and we have the ethyl. The main chain consists of 5 carbon atoms, which means that's a pentane, and the branches are methyl, ethyl. We always begin with ethyl before methyl. Now, in either way you number, it's going to give number 3. So we're going to start with ethyl, 3-ethyl. Then we're going to talk about methyl. It's connected to the third. So it's 3-methyl and pentane. Now in this chain here, the fourth one, we have 3 different branches. So we have to use the prefix tri. Our main chain consists of 1, 2, 3, 4, 5, 6, 7, which means 7 carbon atoms. It's a heptane. Because the branches are identical, we have to use the prefix tri, and we number each branch. We're going to start numbering from Which side? From this side, because the numbers will be 3, 3, 5 instead of saying 3, 5, 5. So the name will be 3, 3, 5 trimethyl heptane. In this structure, as you can see here, we have 1, 2, 3, 4, 5. We have 5 carbon atoms, and we have 4 identical branches. We have a methyl and another methyl, and third and a fourth. Now, if we number from this side or this side, the numbers will be the same. This will be the second, and this will be the fourth. So the name of the main chain consists of 5, so it's a pentane. And because we have 4 identical branches, that's a tetramethyl. We're going to start numbering. The first connected to the second, and the second is connected to number 2 also. The third is connected to the fourth, and the last one too. So it's a 2, 2, 4, 4 tetramethyl pentane.